Good afternoon, everyone, and welcome to our second progress presentation. As an introduction, we decided to do a recap over what our project is and what our objectives are. So essentially, our project is a car park reservation system whereby users are given the capability of reserving their own parking spots in different car parks in different facilities. Through this application, users can register using their emails and their car license plates in order to reserve a parking spot inside a facility's car park. And by the time they arrive at the facility, they'll have their parking spot reserved for them. The main objective behind our project is to help our users find parking spots a lot easier. Not only will this save them a lot of time that is usually wasted in finding a parking spot, but it'll also save them a lot of resources such as fuel and energy. In this presentation, we are going to be showcasing the progress we have made throughout this semester, which includes the development of the first part of our project, which is the ultrasonic sensor module that detects the presence of vehicles and parking spots, as well as a collection of sample data that we have gathered that we are going to use in order to be able to develop our license plate registration program. This is our presentation outline. The first thing we're going to be looking at is our system requirements, or the updated list of our system requirements. Next, we're going to be looking at the design. And finally, we're going to look at the experimental results, which are basically what kind of progress we've made when it comes to the development of the prototype itself.
Our system requirements will include performance, safety, security, and software quality. Our parking spot module will be operational as long as the parking lot is open. So whether the parking lot has certain working hours or it's open 24/7, that's how long the module should be open. The parking module has to accurately depict when a parking spot is taken by a vehicle, and it's not, for example, someone passing by in front of the sensor, or if it's basically any kind of obstacle that's not a vehicle in front of the sensor. Our gate control unit will have a regularly updated list of vehicles, and it will take a snapshot of the license plate as soon as the vehicle enters. And the gate will open only when the image is processed and the license plates are confirmed as like an authorized vehicle. Registration and reservation on the mobile app will be effortless and very user-friendly and can be done in just a matter of seconds. For safety, our app will include a privacy policy because it is the user's right to know what kind of information we're using, how we're using it, the purpose of collecting that information, any kind of data transfer that's happening on the app. We want to basically have full transparency with our users and their information, and we want to let them know that their private information is safe with us. Security will be largely dependent on the report system on the app. How it works is when someone witnesses an incident like a car dent, or if someone left their blinkers on, the witness can just open the app and open the report system, and then they input like a small summary of like what they saw, or they can include a picture even. Then they input like the necessary details, like the car license plate of the car involved, its model and color. And basically, when the report is submitted, it is sent to the respective authorities, basically the parking lot management, and they handle it from there. For software quality, our app will include a responsive map, which shows which parking lots are crowded. It will also show real-time parking spot availabilities. So as the user is reserving their spot, they know they can see which spots are available and which are taken and which are reserved. And there will also be inside navigation. So basically, as soon as the user enters the gate, the app will help guide them from the gate to their parking spot.
Moving to our system design, we will be discussing the material used, the prototype, the system architecture, and finally the functions of the system. The materials are classified into 4 different categories: image processing, checking available spots, connecting to the database, and the software. We know that the basic concept of image processing consists of 3 stages: input, processor, and output. In the input stage, an image is captured by a camera and then sent to a particular system to focus on a pixel of the image that gives its output as a processed image. Therefore, a camera is needed to capture the images, so we'll be using a Pi camera V2. It supports high resolution up to 1080 pixels. In addition, there are numerous third-party libraries built for it, including the Pi Camera Python library that would facilitate processing the image. And in fact, this camera module is very popular in security applications. Also, we'll need a module to process the image, so we'll be using a Raspberry Pi 4 board that is the central module of the whole embedded image capturing and processing system. As shown in the figure, its main parts include main processing chip unit, memory, power, supply, HDMI like the Ethernet port and the USB port. Regarding the connectivity of the Pi camera and the Raspberry Pi, the way we'll be connecting both of them will be through the small socket on the board using the dedicated CSI interface.
For checking the vacant spots, we will be using the ultrasonic sensor to check the availability of parking spots. The reason why we chose ultrasonic sensor is that the ultrasonic sensors can be used in outdoor applications or dark indoor applications, unlike other sensors, especially the infrared sensor that has lots of limitations like the inability to use them in sunlight due to interference. Ultrasonic sensors work using sound waves, and detecting obstacles is not affected by many factors like other sensors, therefore they are more reliable. For transferring the data collected by sensors, an ESP8266 Arduino module will be used to act as a local area network. The reason why we choose Wi-Fi over Zigbee and BLE is that the Wi-Fi average range is between 30 to 100 meters and it's faster than Zigbee. In addition, the Wi-Fi bandwidth is up to 2 MHz. And just for the testing phase and due to difficulties accessing AC Wi-Fi, we will be using the Huawei 4G portable Wi-Fi router instead of implementing our own router, in which this router will be able to connect up to a certain number of devices. Some of routers connect up to 11 devices and other up to 32 devices. It will receive data from the sensors and the cameras and then send the collected data to the cloud to be stored and processed. As for the software used, we will be using the Arduino IDE to program sensors and ESP8266 modules, and for the Raspberry Pi, we will install the Raspberry Pi OS, which comes with over 35,000 packages. And usually the Raspberry Pi comes with a default Python IDE installed, but in case it did not exist, it has to be installed to be able to process the images.
Now that we've seen all the materials used in our system, let's see how they are linked and connected together to form our reservation system. So this is the representation of our whole system, where all components are connected together. It may seem complicated at first sight, but let's break it down to 3 main parts to better understand the functions and capture the whole idea. First, we have the parking spot module, where ultrasonic sensors are used to detect the existence of a car and update the state of the spot accordingly. Next, we have the gate camera, where image processing happens to recognize the car's license plate at the entrance. Finally, we have the user-ended application, where the user can choose the section in which he wants to park and then reserve a spot. Now that we've seen the 3 main parts of our system, let's discuss each one of them in more details. The parking spot module. In this part of the system, we have 2 different components: the Arduino microcontroller, which is the ESP8266, and the ultrasonic sensor, HC-SR04. As you can see, the ultrasonic sensors are connected to the ESP8266 using wires. This ESP8266 works as a control unit and is programmed in a way to receive data from the sensors and sends it using the Wi-Fi module to the router. The gate camera. The 2 main components in this part of the system are the Pi camera and the Raspberry Pi. The Pi camera is used to capture a snapshot of the car at the gate entrance. This snapshot is then sent to the Raspberry Pi through a wire. The Raspberry Pi then takes it from here and does all the processing it needs to recognize the license plate numbers. All image processing will happen locally on the Pi to prevent any delay due to connection in the recognition phase. So this part of the system retrieves the license plate number. And for the user and application, we only have the user's device where the application will be running. Now let's move on to discuss how each part is connected to the other and how exactly does the system work. So as we said, the gate camera part returns the license plate number recognized from the Raspberry Pi. This is then being sent to the router, which then sends it to the database, where we can check whether a user is registered with that license plate number or not. In case of the existence of a user, the gate opens and the user gets a navigation to the nearest free spot on the application. The user then parks at that spot. At that moment, the sensor detects the car, and as we said, the parking spot module returns the current state of the parking spot, which in this case will be occupied. This state is sent through a router to the database to update the number of free spots on the user-ended application.
The system architecture. The system architecture have the user interface, which allows for the information to be presented to the user and for the user to access parking system functionalities by interacting with the user interface, for example, pressing an icon on the page. Then, we have the user controller that has two main components, the authenticator and event controller. The authenticator works on, instead of having to access the database to make sure that the correct username and password have been inserted, our system utilizes the client device's local caches to store and retrieve the data needed to authorize the user login. While the event controller is concerned with taking the user input or user interaction with the UI and handling it in order to update the page view accordingly. Then, after the user controller takes the user input and forwards it to the communication client tier, the communication client tier has two main components. The first one is the send request, in which there are messages sent by the client to trigger an action on the server, while the capture response component is a pack of information sent by application server to the client in response to an earlier request made by the client. Then comes the communication application tier that also has the send response component and capture request component. The capture request component is responsible for capturing the request sent by the client server. In fact, the security has three main components here: the encryption that scrambles the data before it's sent over the database, and the data is accompanied by a key, which is a piece of code that's needed to interpret the encrypted data. And the second component here is the decryption that decrypts the data coming from the database by using the key that accompanies the data. And finally, the application security system. This component encompasses the security that measures, rules, and algorithms they employ to protect the system. Then, we go to the logic layer to execute the request. Logic layer, it has a lot of components. The first one is the chat system that handles the chatting, which involves sending messages to both the technical support team and users who have specified a problem in the application. It also has a general user system component that handles users related to functionalities and information. In addition to that, it has a search system component, and this component handles the search functionality to the user. And the last component is the technical support system, which is responsible for handling the technical support related functionalities and information, such as the monitoring and suspension of user activity. Then, data access layer that executes database related functions relevant to the request from database management. This is responsible for handling anything related to the database, such as the security of the database, backup and recovery, such as the data is backed up regularly, then data is recovered in case a problem takes place. In addition, it can create additional databases.
Now we will be talking about the functions of the system. We will be deeply discussing the use case diagram and the sequence diagram of our system. The system has two types of users, the application user and the technical support. Considering that the general user of the system has already downloaded the mobile application, then the general system user is allowed to register through the application and must enter information such as name, email address, phone number, and vehicle details such as car plates and model. Then the user's information is added to the database and the user can log in by now to the system to start using it. Once the application user is logged into the system, the user can view and edit his or her own profile. And most importantly, the user can search for a parking area and pick area from the available ones, and then the user is directed to another page where he or she can then reserve a spot. Our application aims to provide the shortest path from the gate to the available parking spot, so we will be using the A-star algorithm, which is a path search algorithm and is commonly used for the path-finding problems. In addition, the user should be able to report any problem facing him or her while using the application, such as errors, glitches, or if any of the system functionalities is not operating normally. And here comes the role of the technical support, who should be able to assist users in solving problems faced by them. And after viewing their problems, the user should receive a notification with updates of the reported problem. In addition to this, the user should also get notified after reserving a specific spot with all the information, like for example the spot number and the time limit indicating when the user will lose the reserved spot. As previously mentioned, only the user can reserve a spot prior coming by a certain time, and if the user exceeded that time, the reservation will be cancelled.
Now we look at the sequence diagram for the main feature in our system, which is reserving a spot. So the user starts by choosing a section in the parking area on the application. Then we send a request to the database to check the number of free spots in that specific section. It returns the number of free spots and displays it to the user on the user interface. If there were any free spots, meaning that the number of free spots not equal to 0, the user can go ahead and reserve a spot. By reserving a spot, we send a request to the database to update the number of free spots in that section, and we increment it by 1. This means we had a successful reservation, and we can now notify the user with the time remaining to arrive to the specific section. Otherwise, if there weren't any free spots in that section chosen by the user, he will ask to get notified when there is a free space. And so when a car leaves, the status of that parking spot becomes free, and we update the number of free spots on the database in that specific section by decrementing it by 1. Then we notify the user that there is a free spot, so he can go reserve a spot.
When it comes to the experimental results, we were able to develop the first part of our prototype, which is the ultrasonic sensor. This was a very tricky process, since we had a certain compatibility issue with the hardware we have acquired. The compatibility issue we had was the fact that the Arduino chip was not capable of providing the amount of voltage that the ultrasonic sensor needed, which is 5 volts. The only nodes that were provided inside the Arduino chip were 3.3 volts only. Not only that, but the ultrasonic sensor uses 5 volt logic, whilst the Arduino chip uses 3.3 volt logic. When it comes to the logic level difference between both of these hardware components, this wasn't really an issue, because they were both able to communicate with each other with no problems. The problem was powering on both devices at the same time. We were hoping to power on the ultrasonic sensor from the Arduino chip. However, we've resolved the situation by using a voltage amplifier, which converts 9 volts to 5 volts, which would be able to power on both the Arduino chip as well as the ultrasonic sensor. The next step was to start testing the ultrasonic sensor before connecting it to the cloud. In order to do this, we laid down a ruler right next to the breadboard that we were using for testing, and then we placed a book in front of the ultrasonic sensor and measured the distance and changed it at the same time to make sure everything was working perfectly. And it did. Thankfully, on the serial monitor on one of our devices, we were able to exactly calculate the distance between the book and the ultrasonic sensor. The range of the ultrasonic sensor was rated to be around 4 meters. However, we were able to only reach 2.7 meters. The next step was to make sure that our ultrasonic sensor module was capable of connecting to the cloud. In order to do this, we had to connect our ultrasonic sensor module to our Wi-Fi network and give it a viable IP address, and then connect it to the internet. From there, we were able to connect it to a cloud API. The cloud API we have used is the Cayenne Cloud API, which uses the MQTT protocol. This Cloud API is only used for testing and is not the final Cloud API that we are going to use. This is only temporary. We were able to successfully display the distances that were appearing on our serial monitor onto the Cloud API, which means that we were able to successfully connect our first IoT module to the cloud. After having completed this with one of our modules, we continue to do this for the rest of the modules that we have. Now we have a total of 4 ultrasonic sensor modules that we were able to successfully connect to the cloud, each of them individually and then collectively. The next step in our development process would be to develop the license plate recognition software that we are going to use in our gate camera module. This is going to help us identify as well as analyze license plates of the cars that are in front of the camera and match them with the cars that are granted access inside our car park. In order to develop the software, we're going to be using the myriad of data that we have collected of car license plate photos, which have been taken from different angles, in order to be able to train the software into identifying license plates and the numbers and letters that appear on license plates. This is going to be achieved through the use of machine learning techniques. The final step of our development process will be to develop the user and application. Through this user and application, our patrons will be able to reserve the car parking spots that they desire in the facilities that support our system. Once all of the project elements have been developed and tested, we're going to be connecting them all together into one distributed system. Once we've made sure that our system is fully up and running and that each element in our system is working properly, we are hoping to deploy this product on our university grounds inside the university car parks. This essentially is our empowerment outcome, a community development project. We are hoping to be granted access by the security department in the AUC to be able to deploy our project in one of the university's parking areas. We are intending to develop small modules for that parking area or a small amount of modules for that parking area in order to have that parking area exclusively use the system. This will allow students to be able to reserve their parking spots freely without having to worry about other students coming in and taking the parking spots from them. Thankfully, our development process has been moving smoothly for the past couple of months. We hope that our project becomes a success and that we are able to successfully deploy our project in our community. If you have any questions, please feel free to ask them, and thank you for tuning into our presentation. Thank you.